Hello, hello. Hi, how's everyone doing? It's Alan over here with IVS 360. I am one of the JLR technicians here, and wanted to go over with you guys a little bit on eco stop start technology, brief intro into power management, and ultimately a different diagnostic approach when it comes to eco stop start and a lot of the concerns our customers will have in regards to its function. All right. So let's hop into it. So, just as a reminder here, with a purchase of a DrivePro ES, okay, this offer ends on the 10th, but we are going to be giving out a battery maintainer. Pretty darn good one. Output of 90 amps. Great for quick tests, especially when it comes to flash programming, things of that nature. Definitely a great deal. So, if you guys have the opportunity, go ahead and jump on that, all right? So, boom, eco stop, right? For those of you who do know or don't know, eco stop start is essentially a new emission strategy. Well, not so much new, but newish. This essentially allows a car to come to a complete stop and the engine power down, cutting in fuel consumption, cutting down in overall emissions, right? But how does it work for us? Well, it's really dependent here on what years we're operating with. We, for the most part, throughout Jaguar Land Rover, started to see the emergence of EcoStop starting in about 2013, right? So for the Rovers, we saw them consistently with the L405, 494 chassis, and naturally 13 and on LR4. Carried on all the way throughout present, but we did have a shift in systems as far as system configurations, communications, and monitoring, which occurred in 2016. But although the configurations changed, the overall operation didn't vary that much. Okay. Um, so, first thing we're going to hit here, we're going to spend a little bit of time going over these particular systems to help you guys familiarize yourself with it. We have our dual battery systems. These are the most common that we're going to see out in the field today, right? Dual battery is just that. You have your two batteries, you have your main battery, and you have a secondary battery. And these two batteries do, in essence, work with each other, okay? Our main battery is just that. Its primary purpose in life is to ensure proper voltage during cranking and to ensure that we do have proper system voltage once we do experience that voltage drop and between there and when the generator takes over. Okay. The secondary battery is responsible, and it's kind of a multifaceted battery, right? So the primary purpose of this secondary battery is to ensure that we have stable voltage throughout the vehicle during an eco stop start event. Okay. So as the engine comes to a stop, naturally, engine turns off, generator stops moving, right? So we're not generating any charge voltage. So what happens is all vehicle power will shift over to the secondary battery. And that secondary battery will ensure all comfort systems remain powered and awake. Our powertrain, our CAN all remain awake. So everyone is still talking with each other. The shift from main battery to secondary battery is seamless. Okay. Now, naturally, because we have to facilitate this quick shift in voltage, we have our fair share of control devices. Okay. And we'll cover them as we go down, but just to quickly touch on them, we have our battery monitoring system, right? Which, for those of you who do touch quite a few of these vehicles, that's going to be that little black and white box that's on the end of our, or right at the negative battery terminal. Okay. We have our gateway module, which effectively operates as our not only a gateway module for CAN, but our vehicle voltage supervisor. Okay, we have our PCM, central junction box, which doubles up as our body controller, the quiescent control module responsible for vehicle voltage drain, and then our power supply distribution, which is essentially the junction point of, which battery are we going to be using, whether the secondary or the primary. On single battery systems, typically we start seeing single battery systems in about 2016. Primary reason why we went out to single battery systems is as the dual battery systems remained on the market, we found more so than not they tended to be problematic. Okay, a secondary battery, if it were to be failed, could affect can in certain aspects, will most definitely affect the way that EcoStop operates or even turns on or decides to turn on. So to step away from that, well, we went to a single battery system, which is in essence a capacitive system. Okay, we how now have a voltage quality module, glorified capacitor, that now ensures that we have the proper support for the main battery during that eco stop event. That way we can ensure that our voltage is nice and clean throughout all of vehicle networks, all comfort systems, infotainment, as well as powertrain. Okay. In the single battery systems, the gateway module plays a much more important function and feature when it comes to overall voltage control. So going back to the dual battery, we're going to split this out, and I'll go further into depth as far as the way that all of these components work together. But one thing to keep in mind is between the dual battery and the single battery systems, our control devices remain pretty much the same. It's just we're just down one battery. So here in the dual battery system, for the most part, you have two primary supervisors, two modules that make the decision whether or not we're going into an eco stop or not. And that's going to be your ECM and your gateway module. Okay. These two modules will go ahead and pull inputs from the body controller, the restraints control module, various other inputs throughout the vehicle to be able to determine A, is it safe for us to go into an eco stop? Can I sustain vehicle electronic operation during eco stop? And most importantly, can I start after an eco stop event? Okay, so as you can tell here in the diagram, for the most part, fairly straightforward. Okay, we all start with our main battery. You can see right here at the top left of that image there. And that main battery will go ahead and supply voltage to the starter. We'll get voltage from the generator, and through the BMS, we'll go ahead and report to the gateway as far as the way this vehicle is doing electrically. So then the gateway module can make its determination, say, hey, we are electrically sound, I'm good to go. Our inputs are nice and proper, we're good and safe. Then the PCM and the gateway module will go ahead and either execute the eco stop or the eco start. On the single battery systems, okay, the operation still remains the same. Okay, we have our main battery, same thing, provides power to the starter, gets power from the generator. BMS will go ahead and respond vehicle's battery state of charge to the gateway. But here's the primary difference. Right dead center of that image, which you're going to find, is the voltage quality module. Now remember that. We're going to touch on that. But outside of that, our control systems are still the same. We still have the gateway that will make the ultimate decision if we're electrically sound to go ahead and facilitate that eco stop. We have the PCM that is already transmitting over CAN. Hey, I see a brake input or I see throttle input. We're getting a gear shift request or anything like that. So the controls are the same. The strategies are a little different, but for the sake of diagnostics, I typically advise not to think of them as completely separate. EcoStop in this particular circumstance or for these particular vehicles, you could almost blanket the diag, whether it's a single battery or a dual battery. The one thing you do have to keep in mind are whether or not a component is available or not. In this case, secondary battery versus the voltage quality module. So the battery, well, it's as straightforward as it gets. They're batteries, okay? But this component is the heart and soul of this car, okay? And I've had a lot of guys, say, hey, Alan, I have this issue with EcoStop. I'm not exactly sure where to start. And I always go back, load test that battery, load test that secondary battery, right? Oh, well, my Medtronic says it's good. Well, here's the deal, right? When you're testing with a static charger like that, we're not putting that battery under a load enough to be able to determine if it's good, right? One of the key strategies here that is hard to come by as far as literature goes is the way that the gateway module monitors that main battery. It doesn't really monitor that main battery to determine eco stop when the car is running. It monitors the battery voltage drop during cranking. The strategy behind that is this: is if my battery drops too low when cranking, just right out of a cold soak, then can I really trust this main battery to start this car up in the middle of traffic? Customer safety will always be number one. So load test these batteries. There's a lot of kind of pushback here and there as far as load testing AGMs. I w- I'm all for it. Okay, as long as you're not providing an excessive load for an excessive amount of time, you're fairly safe and it's a fairly reliable test. Okay, so always double back. Make sure your main battery is good. That will forever be step one. Okay, step two, naturally, is you move on to the secondary battery. Now, the secondary battery, I'm starting to see them pop up more and more with aftermarket alternatives. Okay, I will forever advocate that you get a factory secondary battery, just to ensure that we do meet all of our voltage requirements. As you can see here, our secondary battery is going to be a 12 volt, 14 amp hour, or 200 amp battery. Our main battery will always be your 12 volt, 90 amp hour, 850 amp AGM. Very important. Eco stop vehicles will always be fitted with an AGM. So if you get an eco stop start car in, you check that battery and you find out it is a flooded battery, your first thing is going to be replacing it for the proper battery for this vehicle. So don't shy away. And I cannot emphasize this enough. 90% of inoperable EcoStop vehicles in JLRs are battery related or some sort of variant of voltage related. So make sure you always start there, always test your batteries. And then once we determine those are good, then we can move on to checking out some of our control devices. So here it is, gateway module, our supervisor, boss man, and ultimate decider of all things electrical in this vehicle. Outside of being a CAN gateway, okay, the gateway module itself houses the energy management algorithm. It'll determine whether or not we need to shift charging from the main battery to the secondary battery to ensure battery state of health. It's there to determine the operation of the generator to ensure that the generator is working properly. We don't have any excessive AC ripple, anything like that. And it is also responsible for monitoring battery drain, okay, which is also a big contributor in a lot of eco stop issues. Naturally, you got a battery drain going on. Sometimes the customer is not really attuned to that symptom. They might come in and say, "Hey, I have a eco stop light on my dash with a slash going through it," and that's all they're going to tell you. And if they just drove that car in right after having a low battery, guess what? You're going to start that car. It's going to sound pretty good. Okay, so always, let's gather as much information as we can from our customers. If they happen to say, "Hey, my eco stop doesn't work," quick and easy. Have you had any cranking issues, slow cranking, or anything like that? That may clue you into the next step of your diagnosis. All right. So always remember when going back and you're trying to find out who's in control or decision making for our vehicle electrical, that's going to be your gateway module. Our central junction box here. Um, Central junction box slash BCM, many names for the same device. Okay, it's just that. It's our body controller. Okay, over CAN, the CJB will tell the gateway any input data that it's requesting, right? So anything from, is the doors locked, or is the hood open, any ajar signals, um, or any voltage requests, anything like that. All of that gets relayed through the central junction box. Central junction box will update that status over the CAN. Okay, so that information is shared not only with the gateway, but being the fact that it's spit over the high-speed CAN, your PCM will get that info as well. Now, the central junction boxes on the later ones are known for having their little quirks. Okay, a lot of times that we do find kind of anomalous or erratic inputs from door latches, anything like that. I typically always advocate check these connectors. I've had a lot of connector issues with the central junction boxes. I've had a lot of corrosion issues with the central junction boxes. So, always a good place to start. Typically, for most of the JAGs, right? So, JAGs XF, XE, you'll find them there in the passenger side kick panel. XJ, you'll find them by the rear seat, or for those Land Rovers, for the most part, they all reside under the dash behind that glove box. So if you're going through your diag and you're past the point of batteries, don't shy away. Find that central junction box and just disconnect those connectors real quick. Make sure we don't have any green furry friends growing, and then proceed forward from there. So, battery monitoring system. This is essentially our tattletale, right? And probably one of our most misunderstood devices throughout our vehicle management system, or energy management system, I should say. So, from battery draw to charge quality to battery state of charge, all of this is reported through this BMS, or the battery monitoring system, battery monitoring module. Now this guy here sits on the negative terminal. Okay, it's a two-wire module. It has one wire that reports our B plus, right? So literally, if you cut open that harness, you can follow that wire all the way down and around, and then you'll find it coming up to an eyelet on the positive terminal. Now the other wire here, this is our communications line. Okay, this BMS communicates by LIN bus, right? So, for those of you who are familiar with LIN bus, essentially, it's 12 volt on off, on off, on off. But for some of us that don't have the scope handy at the shop, we might run for our meter. In which case, remember, these signals are turning on and off so rapidly. Okay, your meter at best will average the voltage. So typically, what you would find there is going to be about 7 to 10 volts, give or take a couple points here and there. But always, 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 if you have anything like a battery monitor missing message, ensure that connector is fitted. Those wires like to break all the time, especially when slamming in batteries. So be mindful of that. Now, the fact now that we know that this vehicle has a BMS, one of the most common questions is do I have to re-register batteries? Most definitely. Okay. Anytime a battery is replaced, okay, or there is extensive, let's say the battery, the car sits out for a little bit and doesn't get driven, it is imperative to re-register these batteries. As we go along here, you'll hear me touch on the fact that the gateway module, although the vehicle management supervisor has a very lazy adaptation strategy. It likes to hold on to old values, and sometimes it could take 3, 4, sometimes a week worth of driving before that gateway module will adapt to a new battery. So, anytime a new battery goes in, you are most definitely to re-register that battery. Save yourself a little bit of time. Okay. Now, being that it's one of the most misunderstood modules, I tend to come across quite a few faults that are diagnosed differently, or, sometimes we're inclined to go ahead and load up the parts shotgun. Totally understandable. But the system is not as complicated. It's just there's not a whole bunch of literature out on it, right? So here you'll find one of the most common ones I run into, and that's going to be the B11 Delta Bravo 11, which is battery monitor missing message. The most typical one, right? Car will come in, battery light will be on, and you'll get out your multimeter. Cool, looks like a generator. You'll go ahead and stick it on the battery, and guess what? You got 14.9, 15 volts. Okay, well, it's charging a little high. Go pull fault, and you find this coming out of the gateway. This fault in essence is just what it says. That gateway module is no longer getting a status update of our battery. Okay. I'd probably say safely 8 to 9.5 out of 10 times, that LIN line is either chafed, shorting a ground, okay, or um, in certain vehicles, that LIN line is also shared by another component, in which case that component being on LIN may be defective, shorting internally, ultimately taking that LIN bus down. So when that gateway module is screaming out, hey guys, it's getting no response. So always keep that in mind. If you get that fault there in the gateway module and it is a hard fault, make sure you start at that BMS. Okay, check the battery here. All right, you can see we have the BMS right there at the top. Okay, so you got two lines going in and out. You got your monitor line coming from the B plus. Ensure that you have B plus present there, not a volt off of B plus, not 2 volts off of B plus, but whatever you measure at the battery, you should find that equal value on the monitor circuit. Okay, and then go ahead and back probe that connector there at the BMS and verify. Do I have my LIN voltage there? If not, then naturally go ahead and ensure that that line or that specific wire leading back to the gateway module is not shorted to ground, okay, or open circuit. And naturally, go ahead and check your splice points, okay. If there is a splice, ensure to remove the other device off of that LIN bus and see if activity returns, okay. But outside of that, that's all there is outside of or that's all there is for comms between your battery monitor and that gateway. Only two ingredients: B plus and LIN voltage. Okay, so always keep an eye out for that. Um, Moving on here, here's your battery registration, right? So a lot of us are familiar here with the AutoLogic software. I'm going to run you through real quick. I get these questions all the time. Hey, do I have to register a battery? And if so, how do I do it? So it's just a matter of auto IDing that vehicle. Okay, you're going to go ahead and select body systems, select your gateway module. Being the fact that the gateway monitors everyone, make the most sense that she'd be there. Right under gateway module, you have your special functions, and then bam, battery replace. Now, I get this question asked all the time. Well, I got 3 selections and I only replaced 1 battery. Do I have to replace all of them? I have always taken the stance. If you replace 1 battery, the other battery should be tested as well. And if the other battery is in a good state of health, both batteries should be re-registered. We want both batteries to operate together. Okay, we want that gateway module to look at both batteries as equal versus having one skewed value. Okay, I've seen a lot of times a secondary battery goes in, the secondary battery is re-registered, but the main battery is still kind of just standing there, right? So let's just say, 2, 3 days prior, the customer pulled up into their driveway, happened to be on their phone checking, baseball scores or whatever, and battery starts drawing a little low. Well, guess what? You've re-registered that secondary battery, but now that main battery's voltage is skewed, and we know that that gateway module is a little lazy. So unless it can see both batteries operating equally, it will not go into enablement for eco stop. So if you test 1 battery, make sure you test the other battery if fitted, and make sure to register both batteries. Okay, it'll save you a whole lot of heartache. One of the best pieces of advice, and like I say, you can cure up a good amount of eco stop in op concerns with just these steps here. Okay. Now the question is how do we switch between batteries? And this is what we got. We got a power supply distribution box. Essentially, it's just a big relay, right? Um, both batteries, both the main and the secondary battery, are wired up to this power supply distribution box. Okay, and then naturally, that power supply distribution box is responsible for voltage output to our engine junction box. This module or this relay box responds directly to the gateway module over LIN. All diagnostic requests will be done over LIN directly to the gateway module. Okay, so ever in the event that you happen to get a fault in the gateway for secondary battery open circuit or secondary battery charge fault, jump to this lug. Okay, I've seen this lug corrode at times. Okay, what we want to ensure is that we do have battery voltage there. Now, even though our main battery may be within the supply circuit, right? So that means that our contactors are closed for the main battery and our secondary battery contactors are open. That that cable that runs up to that lug should still carry 12 volts. So naturally, if you check there, you find 0 volts. Verify that cable integrity from there to the secondary battery, and then naturally, we want to go ahead and ensure cable integrity on the ground side of that battery. Okay, so that's essentially just our quick switch box. All right, now Jaguar uses a similar power supply distribution box. Nomenclature does change though. Jaguar calls it a dual battery module. Functions in exactly the same way. Okay, when we enter an eco stop and we need to switch powers from main to secondary, we essentially command the power supply distribution, or the dual battery module to switch instantaneously. On the newer vehicles, we'll have a that voltage quality module, which all internal transistor, but the idea is still the same. So if you're getting no switching, or we're getting kind of weird erratic charging issues between the secondary and the main battery, we need to turn and give a real close eye and inspection to this power supply distribution box. Oh, here it is, our voltage quality module. So, like I said, this voltage quality module, I've always thought about it as just this glorified resistor, right? It's a DC-DC converter. It takes voltage, it stores voltage until needed, right? Now, just like in the dual battery systems, okay? We said that when we come up to a stop and that engine dies, we're no longer generating voltage. So rely on an external power supply. For our single battery systems, that voltage, that boost comes from this voltage quality module. Essentially, it'll go ahead and supplement the 12 volts to the main battery, okay, while ensuring that overall system power is stable. So we're not going from, let's say, 12.6 at the main battery and then dropping down to 12.3 or 11.9. This will ensure for the duration of that eco stop, you remain at that 12.6 and constantly remain there. Okay, so for those cars, you may go start fishing around if you're familiar where that secondary battery is. If you do not have a secondary battery and you're either 16 or later part of the 16 model year, chances are you will find this voltage quality module present. Okay, in which case, guess what? There's no secondary battery for you to worry about. You can go ahead and proceed with main battery testing and further diagnosis. Now, EcoStop diagnosing. Um, Before we get into enabling and disabling, I, I, I've always approached the diag from a different point of view. We go diagging cars today because we know for the most part how they work. We know how they work, and we look for what makes them work. I have always approached Eco Stop Start Diag for JLR on the opposite end. I look for what doesn't make it work. There are less disablers than there are enablers, and finding the disablers and determining whether or not those values are valid are far easier than sitting there and kind of milling over, well, I have this, I have this, I have this, this is working, this is working, this is working, going down the list. Next thing we know, we spent the next 3 hours and our lunchtime trying to figure out why isn't this working. All right, but for the sake of going over the entire system, we'll go over enablers, and then we're really going to focus in on our disablers, or inhibitors, I should say. So, enabling conditions. What is the PCM looking for? Well, PCM wants to see a speed over 2.5 miles an hour. Okay. Naturally, before we go into an eco stop, we're going to want to see the vehicle come to us, or sorry, stop from a speed of higher 25 miles an hour. We're going to want to see brake input to ensure that we are coming to a stop. It's going to verify wheel speed. Okay, we're going to ensure that our electrical system and our powertrain systems are fault free, right? If there's a fault present, Naturally, we cannot expect things to start up properly. For all we know, we can enter a situation where we start up and misfire or start and stall. So we must be fault free. Okay, and this is one of the most important ones here. Is we need engine and fuel, or engine throttle and fuel adaptations learned along with cam crank sync. Okay, we need to know these, and it's important that the PCM learns these, because without knowing our throttle adaptations, without knowing our fuel adaptations, we as the PCM cannot determine the proper amount of throttle open, the proper amount of fuel to inject into the cylinder to ensure that we get a clean, smooth, and stable restart. Okay. For cam and cranksync, naturally, we need to know where that engine stops. Okay. As that engine's warring around, that PCM is monitoring cam and cranksync like a hawk. Okay. Last thing we want to do is start up on the wrong leg. Next thing you know, we have misfires, start, stall, and being stuck in traffic is not exactly the best place we want our customers to be. Okay. So that's one of the big things. If you're going in and you've fixed, let's say you fixed a misfire, naturally, we're going to clear codes and go for a drive, right? Sometimes we whip it around the block. Sometimes we go for a slightly extended road test, but typically we'll come in, we'll notice, hey, I never got an eco stop. Check your monitors. Let's see if this thing has put itself in the position where it can, or it has already learned our throttle, fuel, cam, crank sync before going way too far into it. If not, drive the car some more. Okay, typically a generic OBD2 drive cycle gets the job done. All right, but make sure you kind of keep those in mind. All right. So eco start enablers, right? Pretty much anything that would tell the car to say we're gonna go, right? So if you let off that brake, it sees a drop in hydraulic pressure. The ABS module reports a drop in hydraulic pressure. That engine will start. Okay. If there is a selection of reverse or putting the vehicle into drive or sport from neutral, the engine will start. Okay. Throttle input, anything like that. Now, there is kind of a safety net that's built into this gateway. Because of that BMS and how it's constantly monitoring vehicle voltage, okay, it also monitors that secondary battery as well. If vehicle voltage gets low enough to the point where that gateway module is even remotely concerned about a no start, it'll make that decision for you and it'll start it at the stoplight. Okay. So sometimes you'll have a customer that may come in and is like, hey, I get this really erratic stop start at a light, more than likely related to battery voltage. Okay. And then naturally, if there are higher demands electrically, the car will start. So, like, let's say, we're at low fan speed and, we can feel the temperature creep while we're at the light. We decide to go, full tilt on AC. Boom. It will start the car to ensure that you stay comfortable, the customer stays comfortable, and this car will remain operating. Here's our inhibitors. So check this out. We looked at what enablement criteria for starting, what enablement criteria for stopping. This is pretty much what we're looking for inhibitors. Voltage supply, voltage quality faults, and I've been repeating that over and over, and I cannot stress that enough. Always go back down to basics. Check our battery, load test those batteries, make sure they're good. Powertrain faults, okay? Whether it's, anything from a cam sensor to a misfire. Okay, always, always, always double back, perform your full quick test, evaluate the vehicle as a whole. Okay, vehicle mixture faults. Well, if we do have mixture faults there, then we can't really depend on our adaptations to say, hey, we can start this car safely with no stutters, no misfires, or no stalling. So that'll work as an inhibitor. Engine temperature, CAN or LIN bus control. If we cannot facilitate equal communication over the medium or the high speed CAN, we can't trust any of the data that's transmitted. So gateway module will most definitely play it safe and will not allow for enablement. Okay. Ambient temperatures for my friends in either the colder or the hotter climates. Okay, this is a survival strategy. Okay, if your engine temperature is below 0 degrees, naturally, we don't want you freezing in your car when you're waiting for that light to turn green. So it'll ensure it remains running and it keeps you warm. Okay. Then naturally, for those of us on the different side of the spectrum, if it's hot outside, we want to make sure you don't melt in that car. So we're going to go ahead and make sure that the AC stays running, keep you comfortable. Okay. We got our hood door ajar signals. We want to make sure you're in the car. Or, for those of us who hit it, we have that eco stop deactivation switch. Okay. So that's pretty much it, right? We had 2 pages of enablers and 1 page of disablers, which is why I gravitate to diagnosing these cars based on what is more likely to make them break, what is more likely to irritate this system to inhibit operation, right? And if we're able to cut out the majority of what we have to make it work, we have saved so much time. Sometimes it's better for us to understand how it breaks or stops working than it would be for us to figure out how that system works. Now, to kind of emphasize this idea a little bit, just a quick little case study. Buddy reached out to me, and he had this 2016 Range Rover Sport. Okay, it's a single battery system. All right, and it had previous work performed. If I remember correctly, it was some drivability issue. EcoStop didn't work. The vehicle owner was very adamant on having it. Right, wanted to make sure that the trees remained green and the birdies kept on singing. So took it to the dealer. Dealer loaded up the software cannon and fired away. I believe, if I'm not mistaken, it was PCM, TCM gateway, gear shift module, all of this. And I could stand behind it. Some of these vehicles you'll find do have a bulletin, okay? But to be quite honest with you, with how often we experienced eco stop start issues at the dealer, the vast majorities of these bulletins have already been performed. But still doesn't hurt to verify software right before proceeding forward. So I get it in. What we have here is screenshots of SDD, or symptom driven diagnostics, right? The factory tool for those of you who have it or are familiar. Okay. And we just, dived right in, did my quick module check just to see if I had any modules that were off the network that I should be concerned about. In which case, for the most part, everyone was reporting perfectly fine. Nothing too crazy out of the ordinary. So went through and did my symptom selection. Now, for this particular one, I was targeting a very particular test plan. So I detailed it out a little bit further. For those of you who operate or use SDD quite often, you'll know once you hit the screen, the less you tell the tool, the more options or the more freedom it'll give you. But for the sake of EcoStop, I zeroed in on it pretty heavy here. And then we went through engine system starting and our start stop. Okay, let's see what faults we generate, if any, hoping we find a little nugget of gold. And guess what? Nil. Nothing really crazy, right? Now, I know some of you are like, hey, Alan, there's a medium speed CAN bus fault there. You're right, there is. But here's the issue. This particular CAN bus fault is just saying that the heads up unit or the heads up display missed the message from the cluster, right? This doesn't necessarily mean that it's going to affect EcoStop. It's just saying for a second it requested some information and it didn't get it. The CAN faults that you need to be looking for are, for example, high-speed CAN bus off, vehicle communication C off, things along those lines. Things that will tell you, hey, some things can't communicate and I can't tell you what they are, but something's up. Okay, so make sure you keep an eye out for that. But outside of that, when looking directly at this, there's nothing really here. We have some historic faults for, CAN bus. Okay, great. But nothing that really screams out to me, right? Crash input, but that got checked off. So we know that that's pretty good. Cool. So we bounce out to this test plan. Okay, now this is just me touching here. There's a bulletin out for Eco Stop Start System Inoperative. Okay, this ultimately alludes to a gateway module programming, which, based on their repair order, the dealer already performed. So, all right, great. We'll go ahead and consider it done. We'll move on. Let's really figure out what we got going on. So, what we have here is the test plan. Now, I'm going to go back for a second. I just want to highlight something, okay? Right underneath that EcoStop inoperative tab, you have the powertrain stop start system health check, okay? Fairly good tool to have, all right? Could be a little misleading at times, but fairly simple in nature as long as you know what you're looking for. Now, this is our breakdown. This is everything the PCM, the gateway module, is looking for to determine I have everything I need to facilitate EcoStop. Okay, so we're looking down ambient temperatures 30 degrees C, engine coolant temperatures up to par, gearbox is up, vehicle battery state of health is good, both the secondary and the primary, so we're comfortable. But here's the thing: when looking at our dynamic stop inhibits, there's one that drops out. Air fuel ratio adaptations within not within range. Now, I started looking back and forth, and I realized something. Looking at the RO that my buddy had, looking at the RO that the dealer gave us, I noticed between the dealer getting the car and updating it, and the out mileage and in mileage, there was less than 12 miles. She literally drove it home, parked it, drove it to the shop the next day. Cool. Chances are this thing hasn't had the time to learn our adaptations. So it's very hesitant in initiating that eco stop, right? So I said, cool, you got it. We're going to go on our road test. Okay. The road test or the post repair, similar to a generic OBD2, typically I say it's about a total of 14 miles at the most. Okay. The first half of your drive should be highway driving. Okay. We're going to go ahead and do 65 to 70 miles an hour, constant throttle. So no accel and decel, accel, just constant throttle. And then pick yourself a long off ramp and then just throw on your hazards for safety, everyone behind you, and do give yourself a decent coast down. Typically, if I'm at 70, I like to coast down to about 40 miles an hour, at which point, hopefully it's long enough to facilitate that. You can go ahead and come up to a stop at the light. Okay. Then from there, you have about 5 to 7 city miles of city driving and a 1 minute idle. This drive cycle should be enough to facilitate all of our enablements. So at that point, we should learn our fuel adaptation, our throttle adaptation, our cam and cranksync. Okay. Now, the reason I compare this to the OBD2 drive is for that reason, right? Your OBD2 drive or that generic drive cycle ensures that our emissions components are A, reliable, and B, functioning properly. We need to ensure these guys are working right before we can actually start building those adaptational blocks. Okay, so always keep that in mind. Post repair, if equipped with EcoStop, go hit this particular drive cycle, or at the very least replicate the generic global OBD2 drive, and you should by then, on the way back to the shop, experience your first eco stop. Okay. Now, so with all that being said, we threw the tool in the car. I got in the car and we took off. Right. So these portions of the test plan fairly straightforward. I mean, it tells you what to do. Go drive. We exceeded 10 miles an hour. It monitored everything, put it through the drive. I'd probably say this is maybe, so we did the 7 miles on the highway, probably 4 miles into city driving. Okay. And then the tool prompted us to come to a complete stop. Okay. We came to a complete stop. Engine stopped. All vehicle electronics remained on. The very next thing it prompted us was to take off. So we verified our eco stop. Now moving on to our eco start. Okay. Let go of that brake pedal. Didn't even have to hit the throttle before that engine started. Smooth as glass. And done. Right? Tool turns around and says, hey, we hit our eco stop. We had our eco start. All of our adaptations are within range. I like everything we see. We're done here. From that moment forward, on the way back to the shop, I probably gathered a total of 7 additional eco stops. That car never had an issue again, as far as I know. But for the sake of this repair was complete. So this vehicle owner came back. They had their very, very eco-friendly Range Rover set for them, and they're as happy as can be. Okay. Um, so to kind of wrap things up here, once again, cannot emphasize it enough. Test that battery. Okay, if you question the state of health of that battery, for the sake of testing, if you have a battery on the shelf, put one in. For some of the Range Rovers, yes, it's a little laborsome. We have to pull a spare tire out of the rear, but I would advocate for you to spend the 5 to 10 minutes to do that versus wasting hours trying to figure out what's wrong. Okay, if you question it, put a good battery in it. If not, make sure you load test it. Okay, keep your diag simple. Remember our inhibitors. Remember what makes this stop working. Okay, if not, you'll find yourself in a diagnostic rabbit hole trying to check off a list of this looks normal, this value looks normal, this value looks normal. Right? Only target those values when that issue or that inhibitor comes into question. Okay? Check your fault codes, make sure that we don't have anything fishy going on out of our control or our eco stop control. So PCM, central junction, gateway module. Okay. And as always, refer to your service bulletins. There's always nuggets of gold there. Sometimes they give you a super solid place to start, especially if the vehicle is exhibiting a certain set of symptoms. It might be just right for you, in which case you can pursue them. And as always, with every single one of your repairs, okay, whether it's something as simple as a misfire, a circuit fault, or a battery draw, to complete your repair and ensure EcoStop is working at its full capacity, ensure to perform that drive cycle. Make sure you get an EcoStop before we turn around and call it done and give the vehicle back to the customer. Okay, last thing we want is for them to take that car and come back for an EcoStop issue. All right. But outside of that, that's all there really is to it. Okay. That's a eco stop in essence for JLR. Once again, just as a reminder for everyone here, okay, we are giving out battery maintainers here, all right, along with the purchase of a DrivePro ES. So if you guys are looking into it right now, is the time to jump on it. All right. Like I said, these battery maintainers, especially for JLRs and programming, awesome thing to have ready and nearby. Okay. So there it is. All right. If you guys do have any questions that we can't get to in the Q&A, you have our email down there. Feel free, get those questions off to us.
Alan, how's it going, man?
Hey, it's going well. How you doing, man?
Great, great information is amazing. Uh, good stuff. We have a couple questions here if you have some time. I know
Sure.
you're a busy dude, but and there are broken Land Rovers out there to fix it and everything to get fixed. But so we have some questions. You got a couple minutes for me?
Of course, of course.
Alrighty. So so we took an eco start stop class and we spent most of the time talking about batteries. Apparently because the battery is important, right?
Mm-hmm.
So let's talk about battery registration. Again, we had some questions about battery registration. So what are some other reasons that we'd have to register a battery other than eco stop start? Because everybody talks about battery registration, and a lot of people have the same question as to why. So why would we want to register our battery?
So this is the primary reason why we would want to register batteries. Okay, it normalizes voltage output. Okay, so like I said before, these gateway modules are lazy, right? It takes time for them to adapt. So if that gateway module says, "Hey, I registered a low state of charge for our main battery," that in turn, or the reaction to that, would to be to command a higher charge rate or a higher output out of that generator. Okay, in which times now we can start to generate anomalous little can faults here and there. Okay, we can somewhat reduce the life of that generator. Not only that, but as far as the customer is concerned, a lot of us have more than likely have experienced one time or another a low battery warning on the cluster. Okay, this is a result of that gateway module logging that low battery voltage. Okay, so a lot of our customers will come in, and I used to see these day in and day out, right? Hey, I got this low battery light on, but I just replaced my battery. Okay, great. The gateway we know is kind of a little bit of a crumb bum and is going to take us time to get back with us. So if we re-register that battery, what we're telling that battery or that gateway is zero your voltage, and what we have now is good. Okay, and that 9.5 out of 10 times will normalize our charge rate, and it'll go ahead and ensure that we don't have that low battery message on the cluster, which could be a little frustrating at times.
Yeah, I agree. I've had that low battery message pop up a bunch, and it is extremely frustrating. Um, One of the things you touched on before, and that I think maybe we should touch on it again. People are asking about aftermarket batteries for the secondary battery.
Hmm.
You want to touch on that a little bit?
Yeah, so as far as the secondary battery goes and the aftermarket options, I'll be honest with you. Me personally, myself, I have always used the factory batteries. I have seen a couple of them randomly in those vehicles that I serviced with an aftermarket battery, but ultimately, when looking at some of them, the specs as far as output wasn't dead on the money, which can cause issues down the line, right? Just as having a marginally flat secondary, we could start, especially during the switch of eco or anything like that, start inducing, anomalous CAN issues there, vehicle operation issues. I always stand behind the best components or the most reliable replacement components you can get are going to be factory components.
Makes sense. So basically, the rule stands: if you want to play JLR games, you got to pay JLR prices.
That's what it is, and always will be.
Couple more things. This whole start stop system. Uh, what CAN bus is it on usually? The high speed CAN, medium speed. What is it on usually?
For the eco stop,
Yeah.
EcoStop operates over both cans, right? All the data that's derived and processed from the gateway are over both cans. So let's say, for example, door latch. Okay, a door latch input, right, or in a jar signal that will get sent over to the central junction, and that information sits on the medium speed bus, right? Given that that gateway module acts as just that, a gateway module, and sits both on the high speed and the medium speed, it's able to say this: hey, I got medium speed telling me that I have a door ajar, right? Then over
Mhm.
the high speed, it'll tell the PCM, do not go to do not kill the engine, right? I got a door open, I'm not exactly sure what's going on, we're going to keep things running from now until I tell you otherwise.
Cool. Um, so while we're on talking about communications here, you mentioned that the battery monitor is on the LIN bus, and you were talking about if the LIN bus is shorted, obviously we're not going to get any information on the health of that battery. Um, what other modules typically are on that LIN bus circuit uh, that could be shorted out or bad?
So, I'll use this perfect example. Jaguar XF. Okay, there's a singular splice point, and there's only one component: the rear view camera. Right. Most of the Jags actually will use that LIN bus as a wake up signal for that rear view. Okay. For the most part, it's either the rear view. There's another component that presently, be honest, is not coming to mind, but it's something very innocuous, right? Something that we wouldn't imagine being a major contributor to our LIN bus operation. So, as always, when given the opportunity, go ahead and peruse the wiring diagrams, scrutinize that splice or those contributors to that splice. But for the most part, in the Jag world, uh, keep an eye out for that reverse camera. It's kind of a stickler, that guy.
Awesome. So, Adrian Lowe's asked a question. Adrian is a Land Rover guru in Florida, the home of all water intrusion. Um, so he wants to know, like, would it be good to use a load test, like something on the Pico automotive software, where it actually uses the starter to load test the battery, and it actually tells you the health of the battery? Would you recommend doing something like that?
Yeah, yeah, definitely. If you want to go ahead and use Pico's battery load test strategy, hey, I'm all for it. Anything, anything we can do, right? Whether it's the days of carbon pile load testing to the advanced computations of the Pico scope, anything to ultimately determine how that battery is functioning during the load is 100% okay in my book. We just want to ensure that that battery has the ability to sustain stable voltage during a crank situation.
I agree too. I find the best way to load test a component is use the thing that it's working. So
Hmm.
the starter would be great.
Yep.
We had a question on you touched on the secondary battery registration. Is Jaguar the same way? Is there a separate option to recognize the secondary battery?
Yes, yes, there is. Okay. The only thing that differentiates, right? Because we effectively started merging the J and the LR. I'd probably say technologically, completely in 2013. Okay. Now, for some of the Jags, okay, although the gateway module does control, okay, the earlier models, the responsibility was left up to a junction box. The process line goes to the junction. So if you go through the gateway and it's not present there in the gateway, just double back and check service functions, as it may be just a generic service function, which is something I should have touched on. But nevertheless, battery registration, the strategy and the idea behind it still stands the same.
Awesome. So we just got a couple more questions, and I'll let you get back to it. You're touching on that the VCM with the voltage control module there,
Hmm.
which you we were saying is basically like a capacitor.
Yeah.
Jason wants to know, is it basically a capacitor combined with a voltage regulator?
Yeah. One can say. I mean, in true essence, just like I described, it is just that a DC-DC converter, right? So yeah, it is regulated, and if I'm not mistaken, I think at the worst, it has a maximum output of like 600 watts. But with the way that the voltage regulation or voltage or power management is within the more modern Jag, so I'm talking like 16, 17, 18, 19. um these systems are fairly good at quietly shutting down or mitigating voltage dependent on module importance, right? So it may drop out or supply less voltage to one module when it's not needed. But as far as that voltage quality module, yeah, just think about it as a just as a glorified capacitor with voltage regulation capabilities.
Great. And I think Dean had a question. I think it was with your case study when you're going through SDD and you're finding like your TSBs. Was there TSB for battery replacement?
There was. I would have to go back and look at that. Now that particular TSB, okay, particular TSB called for battery testing and if required battery replacement. Early on, we had quite a few techs on the floor where we get something like this. They'd see an immediate battery voltage issue, and then they would just go replace the battery, right? Which for the sake of testing is fine and everything, but that's when I double back and say, hey, load test that battery. A lot of those batteries replaced didn't need to get replaced. It's just the gateway module logged and held on to that low battery voltage. Okay, just did not want to let it go, and then ultimately that ended up in the the low voltage faults or the low battery warning, resulting in needless replacement of batteries. So that's when I go back. Always ensure that you load test that battery. If it's good, re-register and retest.
Great. Now, Bradford wanted to know. He saw that you were showing some SDD screens.
Mhm.
He wants to know if those are available through any of the tools we offer, and how exactly is SDD used through our offering.
So, very, very good question. So, for those of you out there who have the Drive Pro, okay, it's an awesome device because we have remote capabilities. So, for the sake of EcoStop, if we do find ourselves in a certain situation where we've gone through the gambit and nothing shows, we actually have the ability to, by means of pass through, hop on with the factory tool there, take a gander, see a little bit more in depth as far as what that car is reporting, and then be able to return that information to you and send you down the correct path of diagnosing and ultimately repairing these EcoStop systems.
That's pretty friggin' sweet, man.
Yeah, it's awesome.
um, so uh, now you did not mention starter draw, starter that's drawing too much amperage. Could that cause a problem with Eco Stop Start as well?
Yes. Okay, but that's kind of a. I'll be honest with my experience, with these platforms from the emergence of EcoStop, to now, being, for the most part, well in operation. I cannot think of a single time that we had, an excessive pull on a starter with the direct concern of eco stop not operating. Typically, at that point, our customers' concerns tend to be quite different, not necessarily pointing us towards an overall eco stop start fault. But yes, in essence, can it? Yeah.
Awesome. So I think with that, we're going to end it here. We made it about an hour. Alan has to get back to work and fix all of the broken Jaguars and Land Rovers. So we're going to end it there. Guys, if we didn't answer any of your questions, please don't hesitate. Email us at the email address on your screen. That's webinars@opusivs.com. And again, Alan, thank you very much.
Of course, my pleasure. Thanks, everyone. All right, you guys have a good night.
Guys, have a good night.